Welcome to The Explainer. Today we are taking an incredible journey right to the center of our planet using the NCERT chapter Inside Our Earth as our guide. We're going to explore a world of molten rock and, immense pressure to uncover the secrets hidden thousands of kilometers right beneath our feet. So let's dig in.
So, here's our game plan. First, we'll look at the clues that tell us what's actually inside our planet. Then, we're going to start peeling back the Earth's layers, one by one, from the crust all the way down to the core. After that, we'll check out the planet's building blocks. Yep, rocks, and see how they're constantly changing. And finally, we'll wrap it all up with a quick summary. Okay, let's get started.
So, how do we even begin this journey? I mean, the deepest mine in the world is only about 4 kilometers deep. But to get to the center of the Earth, we'd have to dig a hole, wait for it, 6,000 kilometers deep. Since that's just not possible, we have to play detective and look for clues.
Right, that's the big question, isn't it? And since we can't just go there and look, we rely on a couple of major clues. First, just like you see here, we have volcanic eruptions. That fiery molten lava is actually magma from deep inside the Earth, giving us a real physical sample of what's down there. The other big clue comes from studying earthquake waves. As they travel through the planet, their speed and path tell us a ton about the different materials they're passing through.
You know, the best way to picture our planet's structure is to think of it like an onion. Seriously, it isn't just one solid ball of stuff. It's made up of these distinct concentric layers, each with its own unique properties, all wrapped around a central core. It's a fantastic way to visualize what we're talking about today.
All right, let's get to our first stop on this journey and start peeling back those layers. We'll begin right where we are, on the surface we live on, and then work our way down into the planet's super hot heart.
Now, this is what I find absolutely fascinating, the sheer scale of it all. The crust, the ground we walk on, the part that feels so huge to us, it makes up only 1% of the Earth's entire volume. Just one. The mantle completely dominates at 84%, and the core makes up the last 15%. It really puts our whole world into perspective, doesn't it?
Okay, so let's break them down. On the very outside, we've got the crust. That's the rocky shell we live on, and it's super thin. Right underneath that is the massive mantle, this huge layer of hot, kind of semi-solid rock that goes down 2,900 kilometers. By the way, the crust and the very top part of the mantle together form a solid layer called the lithosphere. And then right at the center of it all is the incredibly hot and dense core.
So let's zoom in on that tiny 1% that is the crust. Looking at this, you can see right away that it's not the same everywhere. Nope. In fact, there are 2 very different types of crust, and it all depends on whether you're standing on land or if you're out in the ocean.
Okay, so the continental crust, which makes up all our continents, is pretty thick. We're talking up to 35 kilometers. Its main ingredients are silica and alumina, which gives it the handy nickname Sial. But then you have the oceanic crust, which lies beneath the oceans. It's much thinner, only about 5 kilometers deep, and it's made mostly of silica and magnesium. So, you guessed it, we call that SEMA.
And now for the very center, the core. It's mainly made of nickel and iron, which is where it gets its nickname, knife. Now, the core is actually split into 2 parts. There's a liquid outer core, which is what creates Earth's magnetic field, and a solid inner core. And get this, the inner core is solid even though it's hotter than the surface of the sun. It's because the pressure down there is just so immense.
Okay, we've hit the center, so let's journey back up to the surface. We said the crust is made of Sial and SEMA, but what are those, really? Let's take a closer look at the actual stuff that makes up the ground we walk on every single day.
Well, the answer is actually pretty simple. It's rocks. A rock is just any natural blob of mineral matter that's part of the Earth's crust. They come in all sorts of different colors, sizes, and textures, but they are the absolute fundamental building blocks of our world. And these building blocks don't all look the same, for a very good reason. They aren't all formed in the same way. They fall into 3 big families: Igneous, Sedimentary, and Metamorphic. And trust me, each one has a pretty cool origin story.
First up, we have igneous rocks. Their name comes from the Latin word igneous, which means fire, and that's a perfect description. These are called primary rocks because they're born directly from that fiery molten magma when it cools down and hardens into solid rock.
So, igneous rocks can be born in 2 different ways. When magma cools down really slowly, deep inside the Earth's crust, it forms intrusive rocks, that have big grains, like the granite you might use for kitchen counters. But when that molten lava erupts out onto the surface and cools down super fast, it forms extrusive rocks with tiny, fine grains, like the basalt rock that makes up the Deccan Plateau.
Next up, we have sedimentary rocks. Their name comes from a Latin word that means to settle down. These rocks are basically nature's recycling program. Over millions and millions of years, tiny little pieces of other rocks, called sediments, get broken off, carried around by wind and water, and eventually get squeezed together and harden into new layers of rock, like sandstone. And here's the really cool part about these layered sedimentary rocks. They can contain fossils. The remains of ancient plants and animals can get trapped between those layers as they're forming, giving us this incredible window into the history of life on Earth. So amazing.
And finally, we've got metamorphic rocks. Their name comes from a Greek word that means change of form, and that's exactly what they are. When you take an igneous or a sedimentary rock and subject it to unbelievable heat and pressure deep inside the earth, it doesn't melt, but it completely transforms. For example, the sedimentary rock limestone gets baked and squeezed until it changes into beautiful marble.
And this right here is a perfect illustration. On the left, you've got the red fort, which is built from red sandstone, a classic sedimentary rock. But then on the right, you have the Taj Mahal, which is built from white marble. And that marble used to be limestone, a sedimentary rock, before it got totally transformed by heat and pressure into the metamorphic rock we see today.
So we have these three types of rocks, but the story doesn't stop there. They're all connected in this constant, dynamic process of change. Let's take a look at how this incredible cycle actually works.
Okay, this is the rock cycle. It all starts with molten magma cooling down to form an igneous rock. That's step 1. Then, in step 2, that rock gets weathered and broken down into little sediments. In step 3, those sediments get compacted together to form sedimentary rock. Now, if that rock gets pushed way down underground, step 4 shows us how heat and pressure change it into a metamorphic rock. And finally, if it gets hot enough, that rock melts back into magma, which brings us right back to the start of the cycle. It's a never-ending story of transformation.
Phew, we've journeyed from the surface all the way to the core and back again, and we've covered a lot of ground. So, before we wrap up, let's just quickly go over the most important points from our little exploration.
All right, let's lock in these key ideas. Remember, the Earth has 3 main layers: the super thin crust, the massive mantle, and the dense core made of knife. The crust itself has 2 types: continental, Sial, and oceanic, Sima. Our planet's surface is built from 3 types of rock: igneous, which is born from fire; sedimentary, made from layers of the past; and metamorphic, which is transformed by heat and pressure. And finally, the incredible rock cycle connects them all in a constant loop of change.
We hope this journey to the center of the Earth has helped you get a better handle on our planet's incredible interior. If you enjoyed this explainer and you want more content on geography and NCERT topics, your support really does mean the world to us. So please consider liking, sharing, and subscribing for more. Thanks for watching.